So in control flow, and in particular with lists, there are some special commands that we sometimes use to help manipulate the flow of the program. And these commands are break, continue, and pass. And I'll explain these, but I'm going to go through a few examples that will help illustrate what these do. So the first one is break. And what break allows you to do is to break out of a loop before it's done evaluating. So let's say that you had a while loop that was going to go from 0 to 9 and print out the numbers. You could have a break statement in there that if you could say if the number equals 5, then break out. And then it wouldn't ever print out 6, 7, or 8. And so that's what break allows you to do. And I'm going to go through this example. So the example that I'm going to do is I'm going to try to have the user guess which word I'm thinking of. So I'm going to write the code and then we can kind of explain it a little bit more. So first thing I'm going to do is I'm going to loop forever. So while true. And you're thinking, don't do that. That's an infinite loop. That's not a good thing to do. And normally you'd be right, but this break command allows me to not loop forever. So then I'm going to ask for a word. And then I'm putting a space here because I want their input to be a space away from the question mark. Then I'm going to say if word, and here it goes, equals platypus, the secret word. Then I'm going to print good job, and I'm going to break. And if they got it wrong, then I'm going to print nope, guess again. So, and the way that this works is, so if they got the word right, then I'm going to print this out and I'm going to break. And that means that we're going to cut out of this while loop and we're never going to print this nope, guess again. But if word does not equal platypus, then I'm not going to print good job and I'm not going to break. And the only thing that I'm going to do is print out nope, guess again. So let's try running this. What word am I thinking of? So pencil, nope, guess again. Snow, nope, guess again. And then let's try the secret word and it says good job. And that's perfect. So sometimes you can, sometimes it just makes sense to go through the program like this to say, oh, I want to get the word, I want to see if it's the right word, and then if it is, I'm going to say good job, and then I'm going to break out of the loop and not keep going anymore. And if it's not, then I'm going to do that thing, whatever it is. But often you can get away with, and it's even better to put the condition in the while loop like we've done before. And then do something like this. But unfortunately, this doesn't work exactly the way that we'd hope. And so if we try running that, oops, and we've got a define word. That's funny. Oh, and we also have to say while word does not equal platypus. So what word am I thinking of? So if I say platypus, it's going to say nope, guess again, and then good job. And that's not right. And the reason why is because we never had our condition in here to say, oh, well, if it is the right word, then don't print nope, guess again, but print good job. And so if we had to put a if statement in here to say if word equals platypus, well, if it does not, then print that. So I mean, that would do what we want, right? And it would say, oh, good job. So that does what we want, but that's the same thing. I mean, this is the same condition here and here. So we might as well just do this and break the way that we had it before. So, there are some times where you can do it really easily with the condition being in the while signature, but sometimes it's a little bit harder, and so that's why break is kind of handy. So the next example is going to be using continue, and what continue allows you to do is instead of breaking out and not doing the things remaining in the list or the loop, sorry, it's going to just continue to the next iteration of the loop without doing the rest of the things. So you'll see the example. So in this example, I've got a list of students, if I can spell it right. And another teacher comes to the classroom and they say, hey, I need a third of your students because we have this project. So I need to divvy out a third of my students, and I want to do it fairly. I don't want to just pick the first, third of the alphabet because they're like, oh man, we always get picked. So I want to just randomly pick a third, not randomly, but I'm going to pick a third of my students, just by going by handing them out like A B C A B C. So I'm going to write in a bunch of names here, and obviously you can think about them being all different names, but for the sake of being it for making it easy, I'm just going to name them all kind of similar. So in this example, I'm just going to have name 1, then name 2, and name 3. And then I'm going to do that a bunch of times. So now I have 21 names, and they're name 1, name 2, name 3. So it's kind of like the same as if I would have gone ABC, ABC. But I've got to be able to extract from this list all of a third of every name. And so I'm going to try to grab all of the name 1s and send them with the other teacher. So I've got a loop here. So I've got 4 student in students, and I want to enumerate that so that I can get the index. Then I want to say if so I'm going to do something here. Let's see. Okay, so I'm going to do a little, this is called modulus, and I'll explain that in just a second. So if modulus 3 equals 0, or does not equal 0, then I'm going to continue. Otherwise, I'm going to print the student's name. So let me explain what this does, and then I'll explain more about continue. So if I mod 3, so in elementary school, you probably learned about division with remainders. So if you had 3 divided by 9, then, 27 divided by 3, then you had 9, right? But if you had 28 divided by 3, you had 9 remainder 1, right? And in elementary school, that remainder seemed to be really important. But then when you started to do algebra or calculus or whatever, nobody cared about the remainder. They just wanted a decimal. So then it was 9.33 repeated. But now we actually care about that remainder. And that's what the modulus operator gives you, is it gives you the remainder. And so if we've got I mod 3, so in the case of 0, so 0 divided by 3 is 0. So that equals 0, right? 1 divided by 3 is some decimal, so it doesn't equal 0, right? So then we're going to continue. 2 divided by 3 is some decimal also, so it has some remainder, and that's not 0, so we're also going to continue. But then 3 divided by 3 is 1 with no remainder, right? So then we're going to print that one out. So I hope that makes sense. Let's try running the program. So it prints out all the name 1s, and there should be 7, and there are. So that's exactly what we want. So that's what continue allows you to do, is that it prints out the first one, but then it doesn't print out the second or the third one. Does that make sense? So it prints out this one because it's 0. The index here, I, is 0. So 0 divided by 3 is 0. 1 divided by 3 does not have a remainder of 0, so we continue. Does that make sense? We continue right here when 1 divided by 3, which has a remainder, does not equal 0. So in this example, we were able to use continue to get what we wanted and to print out all the students that were a multiple of 3. So does that make sense? So that's where continue can be kind of useful. In this example, though, it makes a lot more sense to not use continue, because we can put an equals 0 here and then just print out the student. Well, I already have it here. So in this case, that's the exact same thing. We print out all the name 1s, but we did it without needing to use continue. So you can kind of see how sometimes it makes sense to use break and sometimes it makes sense to use continue, but sometimes you can get away without needing to use continue or break at all, just by putting a smart Boolean expression into your conditions. And so you kind of have to play it by ear and see, does it make sense to use it here, or does it make sense to just put it in the condition? And then the final thing that we're going to do is use pass. So sometimes if you're writing this big long program and you're just trying to write a bunch of code, and you don't want to get stuck on a certain piece of the code. You just want to keep writing. So let's say that you knew that you needed to loop over all of the, in the example before, you needed to loop over all the students. Let's do for, so you needed to loop over all of them, but you didn't quite know yet what you wanted to do when you were looping over them. Well, if I just wanted to do this, and then let's say that after I was done, I would say done looping. Well, this isn't going to work because the indentation's not right. I mean, this is valid Python, right? Because it's indented. Unfortunately, this is not valid Python because it's basically saying there's nothing in this for loop. Yeah, so you can see kind of the editor down here that it's saying expected an indented block. Well, to get around that, you can just put pass in here. And what pass is, it's a no-op. So the way that you spell that is noop, but you pronounce it no-op. And what it means is no operation. So basically, it just does nothing. So when we come across this, it's gonna loop all of these times. It's just gonna do nothing for every time that it loops. And really, this is only useful for stubbing your code, for just writing it out really quickly and not getting stuck anywhere. Because sometimes you're like, oh man, I know that I need to loop over all the students, but I just don't know exactly what I need to do when I'm looping. And so you can put a pass in a for loop. You can also put a pass in a while loop, and don't run this one because that one will go forever. And you can put a pass in a if statement. And so it's just a way to kind of stub your code. You can also put a pass in a function, which you'll learn about later if you haven't learned about already. But it's just a way to put something there and not have to worry about what's going to actually be coded yet. So anyway, that's what break, continue, and pass do, and they can be very useful. They can also sometimes be kind of worthless if you know, as we saw in the case with continue, we didn't really need it. So it's just kind of something that you should put in your tool belt and pull out whenever you need it.